Hello, this lesson is about voltmeters and ammeters. Let's understand how they work and their basic applications in a circuit. Stay tuned until the end because we have a practical example to solve and I'll give you a problem to solve also. So before talk about ammeters and voltmeters, let's talk about the instrument that's behind those two, and that's the galvanometer. So in a galvanometer, the current that flows there produces a proportional needle deflection to the force of a magnetic field upon a current-carrying wire. So a galvanometer is an instrument that looks like this, okay? So we have this needle, and the deflection of the needle depends on the current that flows inside the equipment, okay? So for a galvanometer, we know the current sensitivity and the resistance inside here. So why? Well, first, if you have, for example, a current sensitivity of 100 microamperes, right? For this sensitivity here, when you have this current flowing through the equipment, we have a full needle deflection, okay? And let's suppose now that we have a resistance of 25 ohms in the galvanometer, so we can calculate the voltage, right, which would be 2.5 millivolts. So for this case here, with a current sensitivity of 100 microamperes and 25 ohms, we have that this voltage here, if we measure this voltage, we have a full scale deflection also. So it's very good because now we can measure all the voltages and currents below these two values here, just adding a scale to this needle, okay? So at 2.5 millivolts or 100 microamperes, we have a full scale deflection, okay? Half of this, it could be like 50 microamperes or 1.25 millivolts. We have that the needle is right in the middle of the scale, okay? So by this way, we can measure the current or the voltage in a circuit, okay? And that's exactly what's behind a multimeter nowadays. So for the multimeter, what we have a current sensitivity inside here, okay? And depending on where you put the switch here, you're actually changing the resistance of the galvanometer, okay? It has a lot of resistance inside here, and by changing the switch, we're putting like different resistance inside here. So we change the scale and we can measure the voltage or the current in very different circuits or in a battery, for example, okay? So now let's dive in and see how the voltmeter and the ammeter works in a circuit. Well, the voltmeter, keep in mind that for the voltmeter you always have to connect it in parallel to the components of the circuits, okay? Always parallel. And well, for the voltmeter, we want that the resistance of the voltmeter to be much higher than the resistance of the circuit. And why this? Because we don't want to alter the circuit. So imagine we have a circuit like this. We add the voltmeter in parallel to the resistance, for example, but because it's much higher than the resistance of the circuit, the current will flow only through the resistance, or most of the current will flow through the resistance of the circuit, okay? So we're not altering the circuit. Now, if we have that the resistance of the voltmeter is almost the same as the resistance of the circuit, well, now we have a problem because we have now two R's in parallel. So the resistance, the final resistance will be R over 2, and we are altering the circuit. That's something that we don't want to do, okay? So that's why we want to put the resistance of our voltmeter to be very or much higher than the resistance of the circuit when measuring. Now for the ammeter, it's basically almost the opposite of the voltmeter. Okay, for the ammeter we always connect it in series okay, in the circuit, and we want, well, that the resistance of the ammeter to be much lower or much smaller than the resistance of the circuit. Again, this is for not to alter the circuit, because now it is in series. All right, if we have that this resistance here of the ammeter is much lower than the resistance of the circuit, we're not altering the final resistance. Okay, however, if it's in the same magnitude of this resistance of the circuit, now instead of just one R, we have two R's in series, or 2R. The final resistance of our circuit will be 2R. Again, we are altering the circuit like this, so we don't want to do it. Okay? Alright, so now that we've talked about it, it's very important for you to put the right resistance in a multimeter, okay, to select the right resistance in a multimeter and connect it in the right way in a circuit. Otherwise, you may end up with some problems. It may explode in your hand. Alright, now that you learned the basics about ammeters and voltmeters and how they work in a circuit, let's solve a practical example and see how an ammeter or a voltmeter can alter the circuit. Okay? So suppose you measure the terminal voltage of a 1.585 volts battery having an internal resistance of 0.1 ohms by placing a 1 kilo ohm voltmeter across its terminals. So we want to know what current flows, what is the terminal voltage, and how close the measured terminal voltage is to the EMF. Okay, so let's take a look. It looks something like this. We have a battery, and we're measuring the voltage here with a multimeter or a voltmeter that has a resistance of 1 kilo ohms. Okay, so it looks something like this. If we take this circuit here, okay, we have our battery, the EMF and the internal resistance, and we're adding our voltmeter. Okay, see that the resistance of the voltmeter is much higher than the internal resistance of the battery, so that's good. Okay, so let's start our calculations. So we can use Ohm's law simply as this, okay, to calculate the current. So for the current, we have the EMF of the battery divided by the resistance, the total resistance. In this case here is the internal resistance plus the resistance of the voltmeter. Okay, so the current that flows is around 1.58 milliamperes. Okay, for the terminal voltage, well, in this case here we have the terminal voltage is the EMF minus the R times I. Okay, so it's the terminal voltage that flows from this point to this point is the EMF minus R internal resistance times the current. Okay, and we have a terminal resistance, terminal voltage of 1.5848 volts. And we want to know how close this measured value here is to the EMF, the actual power, the actual voltage of the battery. Okay, well, we can make this division here. We take the measured value and divide by the EMF, and we see that they're practically the same. There's almost no difference. Okay, one is 1.5848 volts. That's the measured value in our voltmeter, and well, the voltage of the battery is actually 1.585. So see, that's almost no difference. That's because, again, we have a very high resistance in our voltmeter compared to the internal resistance of the battery. So we're almost not altering this circuit here, okay? And by this we have almost no difference between the measured value in the voltmeter and the actual value of the thing you want to measure in a circuit. Okay, now it's your turn to think about, okay, you have this circuit here, we have our battery, okay, here with the internal resistance, have one resistance here and two in series over here, okay, and various points from A to H, okay. I want you to specify the points to which you could connect the voltmeter to measure the following potential differences, okay. For this potential differences here of the voltage source of R1 across R2, across R3, and across R2 and R3. So what are the points that you should put your voltmeter, okay, you should connect your voltmeter in order to have these measurements. So think about it. For this case also, you can connect the voltmeter in different places to get the same result, okay? But think about it and comment your answers in the comment sections.
Physics doesn't have to be hard. Subscribe to our channel and learn with the geeks.